Ladies and gentlemen, please sit down, especially also the three persons in the rear who don't listen to me, who are still discussing and not understanding that I address them. Please also you should sit down. So we wait patiently until also the people in the rear happen to sit down, which slowly seems to be the case. Okay, let me say a word about the afternoon program. You see there are two coffee breaks very close by. The first one will be here as usual, and we will make maybe a little bit shorter. The second coffee break is not here, but it's downstairs, down where the poster session is. Does everybody know, or who does not know where the poster session is? So in this case, please follow your neighbor and he will tell you. I will tell you. So it's, there is a place where you can enter. There are two main streets, so to speak, down to the sea. And the one not close, one starts here in the big pool, in the big swimming pool, and the other one starts from here more to the right. And if you go down there, then you find a port, like a Greek port, and entry and saying Villa Amorosa. And there you go in, and then you will see the place where the other coffee break is, together with the poster session. Okay? And then we will discuss the posters. That is the afternoon program. Now we start the talks of the afternoon program, and the first speaker is Peter Fettke. He has two jobs, so to speak. One is he is a professor at the University des Saarlandes in Saarbrücken. And his other job is he is a director of one of the research labs of the German artificial intelligence organization DFKI, which happens to be also in Saarbrücken. So he has not to travel a lot for his two jobs. And well, as I said this morning already, he is cooperating with me a little bit, and he will now dwell more deeply in one typical problem. It's not the only one, but that is a typical problem that you can solve with Crete. He himself has an education as a business informatics guy from the famous School of Business Informatics in Münster. Please start.
Yeah, thank you very much. Can you hear me with the microphone?
Not really.
So I changed the microphone. Now it's much better. Yes, thank you very much for the nice introduction, Wolfgang. As Wolfgang already said, it's a really pleasure for me to work with him the last couple of years. And now I will give you a deeper example for using Crete in a particular domain, and this domain is strongly influenced by business informatics. As Wolfgang already said, I'm the guy who comes from the application side, so I'm completely on the opposite side from Wolfgang, who comes from the computer theoretical part, and I think this is the way we really could complementary job for working on Crete. The title of my talk is Systems Mining from Process Logs to System Models. The last day I talked to Wolfgang and asked him if somebody knows in the audience what is process mining. And so my first question will be, does anybody knows process mining? Actually, I see some hands. Oh, wonderful. Nevertheless, I will give you some more deep information what is particular system mining and what is the difference to process mining. The topic of my talk is structured in three parts. First, I will give main motivation, why we are particularly focusing on systems mining and what is the main idea for using these techniques. Then in the main part, I will present you a case study using Crete, and this case study is particularly using Crete for the idea of systems mining. Last but not least, I will give you a small summary and an outlook on ongoing questions and further questions we are currently working on. So let me start. A couple of years ago, there was a cover by the famous Nature magazine, and the title of this cover was Big Data. And if you have a deeper look at the different articles which are dealing with the big data, you quickly find out that this magazine strongly focuses on applications of big data in physics, in chemistry, in medicine, and other natural sciences. In the meanwhile, and I think this is now 14 years ago, in the meanwhile, the term big data, I think, is already becoming a buzzword in computer science and in many more application areas. And particularly one application area is in the context of computer science and business informatics. And there we are using data for gaining insights in different application domains. I'd like to give you some typical examples of domains in which you have lots of data. The standard domain is just you have some numerical data, you have just some dimensions of different values, for example, from a typical IoT system, from an engine or another physical system. And by using and analyzing this data, we try to get some insights into the system and looking deeper at this numerical data. Another type of data which is often used for data mining projects is text data. If you today look on the internet, you have tons of text data, different websites. You have, for example, different blogs. You have Wikipedia. You have customer reviews and e-commerce sites. And you analyze this text data to get some insights. For example, e-commerce shops are strongly interested what is written in the customer reviews. Are there more or less a positive tone in the customer reviews, or are there a neutral or even negative tone in the customer reviews? And such an analysis is typically done by some kind of data mining, which particularly focus on text data. Besides text data, you have on the internet another types of data, for example, graph data. If you look at social networks, Facebook, Twitter, Instagram, and other platform systems, you typically use some graph data to understand the interrelationships between different persons, who likes who is a friend of another, which product is bought by different persons, and this data is typically modeled as graph data, and this graph data is then used to understand and get some knowledge about the domain in which this data typically comes from. But graph data is not only used on the internet. Graph data is, for example, also used for the modeling of biochemical systems. For example, some systems use chemical structures, and these chemical structures are used and modeled by graph data. And then you use some techniques from graph mining to gain insights into chemical reactions or something like that. And as I already mentioned at the beginning of my talk, there's another type of data, so-called process data. And if you have process data, you are able to do some process mining to get insights about business processes. How long does a process run? What might be the next process steps? What are typical problems in the process, and which is typically done by techniques from process mining. Process data is different from the other types of data because the time dimension is particularly important. You have some point in time, and in some point in time you have some evolving of different process steps, and therefore you have some particular techniques, and this is the reason why data mining is differentiated in different types. So you have text mining, you have graph mining, and you have process mining. In the last years, process mining became really a hype in industry, and Gartner made some market studies and found out that the market for process mining is one of the most evolving software markets on the world, because there are so many interesting application cases in different enterprises. And here I have a closer look at the idea of process mining, the typical narrative given by Gartner. On the left top side, you have some real-world activities which typically happen in some firms and some enterprises, some office work, typically paperwork, some workforce systems or things like that. People are doing the typical business jobs. These typical jobs are supported by different types of systems. For example, customer relationship management is used for storing the customer data. We have an enterprise resource planning system, for example, from SAP, which is used for scaling different sales order, for planning the production, and things like that. And last but not least, you have typically many more different software systems which are used for supporting the person who are working for the firm. All these systems generate some typical log files, and an example for such a log file is shown on the right bottom side. There you can see some timestamp information, some information about the activities which are executed by different persons or executed by systems, and you have some more data attributes. For example, here are some resources described which are involved by using this particular process steps. And on the left bottom side, you then see a model which is automatically created, derived from the log file. And this is the main idea of process mining. You have some real-world activities, and these real-world activities produce some data, and these data sets are analyzed to discover the real process. And this is one main idea, that you do not have some abstract models which are modeled at the workshop, at the blackboard. The main idea of process mining is that you can really look at the as-is processes, so you have some shadows of the real processes which are going on in your organization. This is the basic narrative from Gartner. This is the basic narrative which is given by several colleagues who are really involved in the area of process mining. And I think in general, and hopefully if you are not familiar with process mining, you have a general idea what are the main topics of process mining, what is the main idea, and I think it's typically clear if you do not know what is going on in your organization, it is really good that you have a model which might explain what is really going on in the organization. But actually, it is not that easy, and in the morning, the talk by Wolfgang already gave us some insights what is really needed to understand the world, and particularly what is really needed to understand the business process. And Wolfgang already used this slide to argue that you need comprehensive understanding of the world, and to get such a comprehensive understanding, you have some idea of the architecture of the system you're looking at, you have some idea, you need some idea for the statics and for the dynamics in your application domain. And already in the small example I gave before, given by Gartner, you see that there are so many interesting aspects which might be captured by such a model. For example, there was an ERP system, a database system, customer relationship system, these systems all have interfaces, interact together, and while mining different business processes, you need some notion of a system architecture. Furthermore, in the example, we have different examples for different data types. There were customers, there was an order, there was different process steps, and this has to be modeled from a statics perspective. And last but not least, if the customer order is executed by different persons, you need some particular ideas for the dynamics. So the interesting question is how process mining can be used based on the ideas from Crete, and therefore I think there's a little change in the perspective, and this is the main reason why Wolfgang and I are talking not more about process mining but about systems mining, because the architecture matters, so the composition of the system is really of importance. Secondly, the objects in the domain really matter, so you have some kind of data mining which must be done to really understand what is going on. You have the data and the real world items, and last but not least, the causality matters. I already mentioned that the time dimension is very typical to understand the process. This is one side of the coin. The other side of the coin says that to really understand what is going on, you have to understand what are the causes and what are the effects of different process steps. So causality matters. And this is the reason why we use Heraclit and the ideas and concept from Heraclit for doing some kind of systems modeling. So let me start with a small case study to give you some idea what can really be learned from a process log. What is inside such a log? This is a very typical example. What can be seen for data types in different process steps. In this example, you have some timestamps. A customer wants to buy a shirt. Another customer wants to buy some shoes. Some vendor packs the items. The vendor sells the item to a customer, and the customer hopefully pays the items he ordered before. If you have a deeper look, you see that in such an event log there are some objects which are the same in different process steps. For example, the vendor V1 is involved in the first process step, in the third process step, and in the last process step. And so you have different objects in the domain which are definitely used in different process steps. And so the first idea is to have a deeper look at the different events which are associated with different objects. And on this slide you see a simple transformation of the different process steps which are already recorded in the event log, but from the perspective of the lifelines of the 6 different identified agents. So if we have the vendor V1, the vendor V2, and you see the complete log can now be split into 6 different partial logs, but all these 6 different logs are totally ordered and are concurrent to each other. If I now focus on 2 of these logs, for example, the vendor V2 and the client clear, you have two simple subsets of the complete log, and the main idea is that these two subsets form a single module, the module V1 for the vendor and the module clear for the customer. And these 2 modules can now be composed together, but actually at the moment, you see on the left and the right interface is at the moment empty, so it is not very interesting to compose these 2 modules. But it is pretty clear that these items can be moved together, can be joined together if some of the events are moved to the interface. And it's very natural to understand that the vendor and the customer interacts together. So the events will go to the interface, all customer events will go to the left interface, and all vendor events will go to the right interface. And now you see that the event head not on offer are in both modules identical, And as Wolfgang told us in the session in the morning, if two interface elements are identical, then they can merge together. So the two modules, V2 for the vendor and the module Claire for the customer, can merge together. And this is one single element of a flow of events in the system. If you do this not only for one event, but for all 6 of the different agents we identified in the event log, you see a complete run of the system. And you now see that there are different events, and some events are sequentially ordered, and some events are not ordered. This is just one reconstruction of what is really going on in the system, but it's just one run of the system we identified. The second aspect, the second pillar of Heraclit, is to get some ideas about the data structures. In this example, it is very natural that you have different sets. For example, you have a set of clients which represents Alice, Bobs, and Clara. You have a set of vendors, vendor V1, vendor V2. You have a set of cashiers. This example, there was only one cashier. And of course, you have a set of items, hat, shoes, and shirt. And as a first step of generalization, you might introduce some kind of signature for this particular structure to represent these particular items and data objects in that domain. By doing that, now the interesting question is to generalize the occurrence items of the system to some kind of systems atoms, because in systems mining you don't want to get some insights about the current situation in your organization. You like to get some generalization. And so the question is how you might generalize some of these occurrence atoms. And I'd like to give you an example for the occurrence atom on the left top side, shirt to take home. And this is a typical occurrence atom of the system. And what is now possible, that you try to identify different objects which are involved in this event. And the event shirt to take home resists on the precondition vendor V1 is available, and the customer Alice wants a shirt. This is a typical situation which can be generalized in the form that you have a place available vendors. On that place, the vendor V1 is actually, and you have a second place, clients X with this description set of item set, and on this place you have Alice who wants to buy a shirt. And by doing that, you have the first generalization of an occurrence atom. And on the other hand, this kind of generalization can be seen as an instantiation, as a particular instantiation better of a particular object of the signature. And on the right hand side, you now see the system atom. And in the system atom, you see that there are general variables as inscriptions on the arrows, so that it is a generalization of the item to take home event in this particular example. And on the right hand side you have now a system atom which can be instantiated with different objects of the signature. In this example you have just instantiation V1, Alice, and shirt. If you do this for all the occurrence atoms in the model, you come to this model of system atoms, and now you have a generalization of the run of the system. And this is the first step to get some system model. Of course, in this model, you see that there are already that there are still many places with same inscriptions. I marked these places in the same color. You see that the place available vendors are in several places in this net, and the only step now necessary to generalize that you merge different places just together, so you merge all yellow places together, you merge all red places together, and so on. And if you do that, you come to some kind of system model, which explains the behavior of the event logs which are descripted in the system. One little technical explanation and extension. This is now a system model, and typically you don't want a system model, you want to have some kind of schema for different systems. And as you remember, Wolfgang already explained the notion of the N operator. So on the right-hand side, there's a schema model, and on the schema, you don't have particular instantiations of the signature. You have just the symbol VE for the vendors, you have just the symbol CL for the clients, the symbol CA for the cashiers, and no symbol for the finished client, which is not necessary in this example. And so on the right-hand side, we have a schema model for the possible systems which can be instantiated by the schema. So, this is the main idea, how you can use Heraclid for do some kind of systems mining. And as you see, that you now have a schema which gives you a much richer information what is really going on in this information. All this model is done by using the concepts and ideas for Heraclid. So let me summarize my talk, how to mine a system model, how systems mining really works in a nutshell. You start as typically from a typical systems log, and in the first phase you try to get some understanding how these events in the system log interact together. So you try to build some kind of run, and this run describes what is really happening, what has happened in the past in my system. And in the second phase, you try to generalize the runs you derive from the system, from the event logs, to some kind of system model. And then you have a much richer explanation and description of the systems you are currently working. Let me give you some outlook on what we are currently working on. It is clear that systems mining can be used in different phases of a traditional business process management lifecycle. The results of systems mining can be used for some kind of strategy development, for the definition and modeling of business processes, also for the implementation of new systems, for the monitoring and controlling and optimization and improvement. We have a much richer information compared to classical, traditional BPMN style models for describing the business processes. Currently, we are working on some kind of tool support. At the moment, we don't think that there will be one single monolithic tool which supports all kinds of functionality which are really necessary for such a round-trip engineering. I think it is much more realistic to have an ecosystem with different types of systems, and we're experimenting with different prototypes for supporting Heraclid in different phases of business process management. We're currently working on different laboratory and field studies in using Heraclid. And of course, what is very interesting to do some kind of conformance checking. For example, if you have an explanation of the current situation, it is interesting, are there some violences compared to predefined rules? Is the actual process really conformed to my business implementation? And of course, the idea of using the mine systems model for some kind of systems prediction is something we are currently working. We do that, but only from the perspective of academics. Last year, some colleagues of DFKI founded a new company, Expect AI. Wolfgang and I are two scientific advisors in this company to give some ideas how Heraclid might be used in practice. And this is one interesting stream of work we are currently doing in Saarbrücken. And last but not least, I'd like to invite you to support Crete from the development and academic perspective. Thanks for your attention. I'm looking forward to your questions.
Okay, Peter, thanks a lot for your talk. I assume there are many questions, but you have to go first.
Thank you for your interesting talk. Maybe one comment and one question. The provocative comment would be, this morning we heard all the computer scientists first program and then model, and that's completely wrong. When I go to the logs, we have programs that produce logs, so isn't that the wrong way around? And then maybe Carl's for the question for that. If you get some insights on the study of the model or model out of all these logs, do you compare it with sometimes systems have been modeled in UML or whatever, or in BPMN? Do you compare the results of your extracted model with the intended models that have been there maybe in some software engineering process, hopefully?
Let me answer your second question first. I think it's very interesting to compare the results. We did it on some small-scale projects, but actually I cannot report from some larger evaluations of comparison to different modeling techniques. Your first question, I think you're totally right. It's a little bit in contrast to that what Wolfgang told us in the morning. You're really wrong, really right. On the other hand, I think it's an old discussion which goes back to philosophy. How do you gain some insights about the world? Are you more empirical driven or are you more theoretical driven? And what comes first? Comes first our ratio to think, or comes first our ability to sense the reality? And actually I think you have to combine both worlds to really get a comprehensive understanding. And I think this is a major important and a major advantage of the ideas of Crete, because you don't have so many pre-assumptions which you have to buy in before you can actually model. All the modeling constructs in Crete are explicitly defined, and you don't have so many objects which are just brought in because you are using UML, because you're using BPMN. So the set of accepted basic terms are so huge, and in the talk in the morning by Jakob, there was a paper citing from the Axiomatisierung der Mathematik, and in this paragraph was the main idea already presented. You have to use almost a small set of basic terms, and I think this is a major example, a major advantage of Crete.
I fully agree, because I think this idea going from the existing logs and finding properties in the system that the people who wrote the systems didn't know of is a good point for doing this kind of modeling first.
Let me comment also on this. This is the situation we found. Therefore, we reacted on this situation. So, other questions? You have no comment? Frank has no comment.
You don't want to hear it in public? No, it's not. No, it's not good. I'm sorry. It was a business comment. No.
You do not want?
No. After the session.
Somebody else? Everybody?
So, Peter, what do you do if the event logs are no good?
If the event logs are bad, then I think it's often not a good idea to start the system development from the experiences from the past, and I think you should use some other type of gaining insight from reality. And I'm not absolutely fan of systems mining. I'm just saying that if you have some event logs and if you have some information, it is always a good idea to use this information. And I think if you have a comprehensive understanding of reality from the architecture perspective, from the statics perspective, and from the mathematics perspective, it is a good idea to use all data which is available, and this is an example how you can use that.
Thank you.
Okay, some other questions? If this is not the case, we thank you again.
Before we leave, we have a second positive corona tested person, so it gets a little bit dangerous. For this reason,